Hello and welcome to video number 7 in this series, and in this video I'll review how to do arithmetic using numbers with exponents. So if we have a to the m and we want to multiply by a to the n, so same base and exponents of m and n, we just add the exponents together. So for example, 2 cubed times 2 squared is 2 to the 3 plus 2, 2 to the 5. And we can see that makes sense if we write this out, because we'll have 2 times 2 times 2 for the 2 cubed, and then 2 times 2 for the 2 squared. And we can see that we don't really need the brackets here. We've just got 2 multiplied by 2 5 times. If we have a to the m divided by a to the n, then we subtract the exponents. So for example, 2 to the 5 divided by 2 cubed is 2 squared. And that makes sense too, because if we write this out, we've got 2 times 2 times 2, 5 of these guys, divided by, in the denominator, 3 of them, and then we could cancel 3 sets, and we're left with just 2 squared in the numerator. And then the next example of arithmetic with exponents is if I have a to the m and then I raise that to the power n, then we multiply the exponents, m times n. So for example, 2 to the 3 squared would be 2 to the 6. And that makes sense too, because 2 to the 3 is just 2 times 2 times 2. And if we square it, we're multiplying it by itself. And so, again, the brackets don't really play a role here. We've got 2 times 2, 6 times. So let's just work through a few more examples and throw some negative numbers in there to make sure that this works even when we have negative either bases or exponents. So let's try minus 2 squared minus 2 cubed. So according to our method up here, we add the exponents because we've got the same base. So that's going to be minus 2 to the 5. And so 2 to the 5 is 32, and then we've got a negative sign. And because it's an odd exponent, the answer is going to be odd as well. So we'll have minus 32. Let's try 2 squared and 2 to the minus 3. So we're multiplying these two together. And we just add the exponents, because we have the same base. And 2 minus 3 is minus 1. And remember, the definition when we have a negative exponent is that's equivalent to 1 over 2 to the power 1, which is just 1 over 2, which is just 1/2. Next example, let's do minus 2 squared over minus 2 cubed. So this is this example here. So we subtract the exponents. So I'll just write down the base and then subtract the exponents. 2 minus 3 be minus 1. Remember, minus 1 means put it in the denominator. So we have 1 over minus 2, and another way of writing that is just minus 1/2. And then let's do 2 to the minus 2 over 2 to the 3. So write down the base, subtract the exponents, minus 2 minus 3, so minus 5. That's the same as 1 over 2 to the 5, so that's the same as 1 over 32. let's do some examples of this pattern here, where we've got an exponent and then apply another exponent to the whole thing. So we'll do -2 squared, and then we'll cube that. So in this case, I multiply the exponents. So write down the base, multiply the exponents. So 2 times 3 is 6. And so now I've got 2 to the 6 is 64. And I've got an even exponent. So the negative sign, if I've got an even exponent, it'll become a positive. So that just stays up, plus 64. And then one last example here. Let's do 2 to the -2 cubed. So write down my base, multiply my exponents. So 2 to the -6. So that's the same as 1 over 2 to the 6. So that's equal to 1 over 64. So that's working with numbers. These rules also apply when we're dealing with variables. So let's do a few examples with variables. So for example, if we did 4, say x to the 5, and then 3x to the -2. So I want to collect together like terms. So I'll collect together constants, and I'll collect together variable terms with x. So 4 times 3 is 12, and then x to the 5 times x to the -2 would be x to the 3. And then let's do a division example. Let's do 4, say x cubed, and let's do 2x to the 5, say. So now I'm going to have, so 4 divided by 2 will be 2, and then x to the 3 divided by x to the 5. So I subtract the exponents, so 3 minus 5, I have to have x to the -2, and x to the -2 is just x squared in the denominator. And then let's do just one more example. Let's do x to the 4 y squared, and let's have an x to the -3 in the denominator, and also let's have a y to the 5. So looking at the x's, I've got 4 minus -3. So that's going to be x to the 7. And I've got, for the y's, I've got 2 minus 5. So that's going to be y cubed. Let's explore a few more rules around working with exponents. If I have a product of two numbers or two expressions, a, b, and I have an exponent applied to that product, that's the same as if I apply the exponent to each piece separately and then multiply them. And so an example here is, let's suppose I have 4 times 2, and I square that. So one way to calculate it would be to multiply 4 by 2 to get 8, and have 8 squared, which is 64. Or the other way is to apply this rule here and apply the exponent to each piece separately. I'll have 4 squared times 2 squared, which is 16 times 4, which is 64. Similarly, if I have a quotient, a over b, and I apply an exponent to the quotient, I get the same answer if I apply that exponent to each piece separately and then do the division. So for example, if I had 4 over 2 squared, I can either do the 4 divided by 2 first, which would give me 2, and then square it. So that would be 4. Or I could do 4 squared divided by 2 squared, which is 16 over 4, which is 4. And this idea here also applies when we have variables. I've just given number examples up to now, but let's do some examples with variables. So let's do 2x y to the minus 1 and the whole thing to the minus 2, and then let's have an x minus 2 and then a y squared, and let's cube all that. So looking at any constants first, got a 2 here to the minus 2, so that's going to be 4 in the denominator. As far as the x's go, I've got x to the minus 2 and then x to the minus 2 cubed. X to the minus 2 cubed would be x to the minus 6. I've got x to the minus 2 here, so I've got x to the minus 8. And then the y's, I've got y to the minus 1 to the minus 2, so that's going to be y squared. Minus 1 times minus 2 is 2. And then I've got y squared cubed, so that's going to be y to the 6. So y to the 2 here, y to the 6 here, I've got y to the 8. And then it's often good practice to express any final number without using any negative exponents. So the way to express a number with a negative exponent in a different fashion that doesn't use a negative exponent is to place the base in the denominator and make the exponent positive. So this is going to be the same as 1/4 of y to the 8 divided by x to the 8. And another way to write that in a shorthand way is like this. So y over x all to the power 8. And let's do one more example using variables. Let's do 2x cubed, and let's put a y in here, and let's apply a 4 to the whole thing, and then let's do a division for this example. Let's do 5 and then xy squared, and let's square that. So looking at the constants first, I've got 2 to the 4, which is 16, and then I've got just a 5 in the denominator, so I've got 16 over 5. And then looking at the x's, I've got x cubed to the 4, so that's going to be x to the 12. In the denominator, I've got x squared, so x to the 12 divided by x squared would be x to the 10. And then the y's, I've got y to the 4th power, so in the numerator I've got y to the 4, and then in the denominator I've got y squared squared, which is also y to the 4. So the y's are actually going to cancel out here, and that's my final answer. At this point, pause the video and see if you can work through the next 2 problems that I'll write up here and simplify them using these ideas that we've gone through in this video. So for the first one, work on simplifying this expression here. I'm going to have x y squared, and I'm going to cube that, and then we'll have 2x to the 4th power, and then a y, and we've got a minus 1 exponent for that. And then the second one, let's do 5, and then x squared y to the minus 2, and we'll cube that. And then we'll divide all that by, we'll have a minus 3, and then an x, and then a minus 1, and then a y, and we'll apply a square to that whole term. So let's see how you did on this first one. So first of all, looking for the constants. So we have a 2 here with a minus 1. So that's going to be 2 in the denominator. As far as the x's go, we've got x cubed, and then x to the 4 with a minus 1. So that's going to be x to the minus 4. So x cubed times x to the minus 4. 3 minus 4 is minus 1. So x to the minus 1 is x in the denominator. And then the y's, we're going to have y squared cubed. So that's y to the 6. And then we've got a y to the minus 1. So we've got y to the 6 times y to the minus 1. So we've got y to the 5. And then for the second one, so let's look for the constant terms first, just the numbers with no exponents. Sorry, no variables. So we got 5, and it's not got any exponent with it, so that's just going to be 5 in the numerator. And then in the denominator, we've got minus 3 squared. So we've got 9 in the denominator. And then the x's, we've got x squared cubed. So that's going to be x to the 6. And then we got x to the minus 1 squared. So that's going to be x to the minus 2. So x to the 6 in the numerator, x to the minus 2 in the denominator. 6 minus minus 2 is 8. So I have x to the 8. The numerator. And then the y's, we've got y to the minus 2 cubed, so y to the minus 6. And then we've got y squared. So y to the minus 6 in the numerator, y squared in the denominator, minus 6 minus 2 would be minus 8. And that is the same as y to the 8 in the denominator. So this is one way of writing this final answer. Another way is to write it like this, as 5 over 9 times x over y to the 8. So that's it for this video, and in the next video I'll continue our exploration of exponents, and we'll look at exponents that are fractions, and that's going to lead us on to a discussion of roots.